Hello. Hi, guys. My name is Amanda. I'm from Brazil. I studied at the university called the Federal University of Bahia. And I'm here to present a paper entitled Evaluating Diversification in Group Recommender Systems. We write it with the final experiments from my master degree. So here is a brief schedule where I will first make an introduction, talk briefly about some background techniques, get into the group model recommendation, show the experiments, and conclude. So, group recommender systems are systems that have the role of finding what's relevant for a group rather than an individual user, like most of recommender system is. Most of GRS do this basing themselves in a group profile. They model the group preference into a profile and made recommendations over this profile. However, this technique may end up recommending very similar items to the group of users. It may tend to fall into this condition. And to avoid this problem that's called over-specialization, it is important that the GRSR can diversify recommendations in order to improve the quality of the group recommendations and satisfaction. So, what are aggregation techniques? I mentioned that the GSR creates a profile, but how can it be done? An aggregation technique is basically a consensus functions to model the user's preference matrix into a group profile. In this example here, I show you guys 3 different aggregation techniques that run over a matrix of user preferences. In the table, you can see that there is 3 users and their ratings. You can see that it varies from 0 to 5 over 4 items: Titanic, Matrix, It, and Wally. Using the least misery technique, that's the first one, you can see that these aggregation techniques choose as the group node for that item the least value for any user in that matrix. In Titanic here, you can see there the user 1 hated it as 2, the user 2 3.5, and the user 3 5. The least misery considers 2, the least score, for the group itself. The second technique, the most pleasure, it's the opposite. It considers the highest score for any member of the group as the group score for that item. And finally, the third technique, that's the technique that we used in our paper, is the average without misery technique, a combination of 2 techniques. That's the average. You make an average of the user's preferences of an item, combined with the least misery technique. And then you can reach the group profile. The second important background that I want to talk to you about is how can we diversify recommendations? What are diversification algorithms that are basically a kind of function that indicates how different or how dissimilar a pair of items is. In this example I bring here, there is the original list of recommendations that's only rated by score. And the 2 other ones, the middle one, is a list with the bounded grid selection applied. That is a diversification algorithm. And the third one, another different algorithm, that's the bounded random selection. So what it do is basically re-ranking the original list based on the features of the items in this example. So the group recommendation model, that in this scenario, that's our research is, our GRS will recommend a group of movies that in this case is represented as I1, I2, and I3, to a group of people. So this model was first introduced in our previous paper. And in this one, we will talk briefly about it to show the different results we got from different experiments. So first, we need to collect the preferences of the users and the items descriptions. Then we can analyze the data in order to find what features are crucial to our similarity functions and to clean the data, taking out any noise that can affect badly the recommended model. Then, after that, we can properly make the group profile. We do it basically fitting a group of people, fitting people into a group, and comparing, getting into the group profile using the aggregation techniques to finally, once we know what the group likes, made the recommendation. That it is the step 4, where we set a list of candidate items, we construct a similarity matrix, and calculate the score and the relevance of the candidate items for the group. Then we do the diversification. That's basically we rank the top K items and present the new list to the group. And finally, we evaluate it. We evaluated the experiments using the NDCG and the precision as accuracy map, quality maps, metrics, and we use the RMSI, and also it's not included here, but we use the ILG to measure diversity. So just as we quickly zoom in the step 4, that is our recommendation model. Our model uses content-based recommendation. So we need to know and model well the item features of our dataset. That I didn't mention in the presentation, but it is the move lens. We recommend moves to the users, so we prefer to follow with this. The first thing we need to do is define what candidate items is, which items are the candidates. Then we can sort it based in the group profile to calculate the relevance of the candidate items. This relevance is calculated based on the relevance, the similarity of the candidate item to the group profile preference. Then we can finally diversify the lists. In this figure here, the first set of lists is from a traditional recommendation model. It's like if we stop in the step 4 in the model, we could get this list. And after the step 5, there is the diversification, we can get the list below. That is the diversified recommendation. It is important to notice that in the traditional recommendation model, consider genre as a feature for showing diversity of the items. We can only see some diversity in the 7th item of the list, because I know this group is very interested in action movies. So it is natural that those items are in the top list. However, this group also showed some interest in other items that is showed in the diversified recommendation. In the top 3 of the diversified recommendation, we can already see some diversity. In the top 5, also we can see diversity. And it is very important to state that both lists are made of the same items. They have the same items. They are only present in a different order for the group. So we ran some online experiments, and we needed to find volunteers in the university. We've got 24 volunteers in our research. We needed to collect the preferences, the participant preferences, and in order to do that, we developed a web system. And then we needed to generate the groups, and we didn't really set any heuristic for that step. We just ask the participants to form groups. The only limitation we imposed was groups of 3 and 5 members. We didn't want it to get very uncontrollable. And then after that, we generate the recommendation lists with our proposal and with the baseline that we use to compare. And finally, ask the participants to assess the recommendation lists. Here are some results of our experiments. The NDCG metric is related to basically to the order of the items recommended. And we looked at the 3 levels. The level 3, that's only the 3 items of the list. How is the NDCG performing that at level 5 and at level 10? It is important to notice that the groups with size 5 performed more consistently than groups of 5 of size 3. Yeah, the group of size 3 is the group that performed the highest, scoring 0.86, and also scored the lowest, scoring 0.67. So the group of size 5 is more in the middle of it and more consistent. Here is the precision at metric for each level, level 3, level 5, and level 10, and for each group. Also this step here we could assess using our proposal and the baseline in order to show you guys it more visually. The bars in the back are related to our proposal, and the more thin lines in the front is the baseline. So our proposal achieves better scores in precision at. I cannot say that it's always better because there is one point where the baseline supered us. There is in precision at 10, and for the group G33. That's the point where baseline scored better than us, but overall, our proposal scored best in precision. And the next graph, this here, show it's better. That's the mean of precision that we've got. Also at the 3 levels, level 3, level 5, and level 10. It is important to notice that our proposal, at the lowest point of it, that is 0.44, still is better than the best performance of the baseline. This is a remarkable achievement. And finally, we assess the ILD, that's the acronym for intra-list diversity. It's a metric related to the diversity itself. And in this metric, the baseline overcame our proposal with a higher score, 0.96, and a lower STD, 0.1, while it was scored 0.94 with the STD of 0.02. However, it is important also to highlight that both approaches, scored really interesting results. Both of them are over 90% of diversity. This metric, the ILD, it varies from 0 to 1, meaning 1 is the most diversified possible in that list. So to conclude, this paper, we evaluated a group recommended system in terms of diversity, and the results obtained with the experiments indicated that the proposed model provides relevant recommendation to the groups, while it still keeps the diversity high in the lists, the recommended items. And for future work, we plan to try different heuristics for group formation. How could it impact the results? Also, we plan to explain recommendations for the group members, because maybe the members didn't really understand why they are receiving that recommendation. because they don't know it, they just receive the item. So if we could explain it to the user, we think it could impact also the satisfaction of the final result. And lastly, but not least, we include more descriptive features in the dataset to improve our similarity function. We tried to do this during our research, but we didn't get a good coverage. So we decided to drop it, but still it's some future work that we plan and consider doing. This is my reference. And thank you, guys.
Amanda, what do you think about the size of the groups? Do you think it really matters if it's 3 people, 5 people, 10 people? For example, if we arrange now for going out in a restaurant, and maybe if we use our system, do you think if you're 10, it perform better than if you're 3?
Well, it's a very interesting question. It really depends on the context we are applying the model. For the context of group, we didn't consider very large groups because it's not a very common situation, unless that we are talking about everyone in a movie room, but everyone got there for the same reasons, not like, you know, sitting with your friends and try to decide something to watch on Netflix. It usually don't go over 10 or 20 people. So to go to the restaurant, we can use it. It's just you need to choose the crucial features of the restaurants to put in their similarity function, and also analyze the size of the groups that that situation requires.
Okay.
But it could be applied.
Yes. Be careful when you say things like fantastic results, scientific context. Slightly unscientific and small reports.
Yeah,
But nice presentation. This is not my area, but you have processed. No, it's really fun. I find it very interesting. Don't you feel though that the forming of groups is part of this problem? Shouldn't they be together? But I'd like to know what's the use case for forming these groups, which you're saying are very small. What are you going to use your method for? If you're saying that it's not normal to have really big groups, like something like everyone in Netflix, what do you use this for?
That's a very
Just trying to find a use case which is applicable for the method, which is interesting to me.
When I first started to do the research, I was thinking about the situation I just mentioned, you guys. So how could we choose something to watch in a streaming movie? That's in a reunion of users. And with this in mind, we started to develop and tackle and try to follow into this path of context to apply the group recommended system.
It's a really question. You can use this, for example, when you were saying that if you are with our friends and then you want to select a restaurant, a film, or even I've seen applications where, for example, if you are in a gym, when you log in the gym, there is like a profile of the music the people in the gym like. And then the music that's playing selected according to the people that is at that moment. So there are some applications where group recommendation is interesting, but I think it's an area that has not been no.
That's a really good point. So I think when you do presentations, this time it's really good to say this is the reason why it's super important. Cool.
And I've been working on this area a bit some time ago, and I will maybe recommend you to look at the work of Lara from a Spanish city, how developer is in this area and develop this concept of diversification and how to solve this problem of to select which films to recommend. And also it has been applied in the tourist domain. For example, if you are in a group of friends and want to visit some places in a city. And also regarding the group formation, because there are some works that when you have many people, try to group these people into similar people to, for example, if let's pick an idea that you are in a bus, 40 people, and then you have 4 tourist guides, and then you can split that big group into smaller groups so that the planning of the visit is more personalized for these small groups and things like that. So I think there is a lot of work to do in this. I don't think it's very
Thank you for the consideration.
I have WhatsApp group, and with my working colleagues, and I'm tired of going to one of the same restaurant. So they, I will be happy to get recommendations. Oh, it's interesting.
Yeah, but that's an interesting question. The comparison was with another method, but you produced the same results, just in a different order.
Mhm.
So, yeah.
Yes.
Yes.
Going to listen to music or something like that.
Yes.
So I think it's maybe very interesting to have a randomness, obviously. Yeah, here you choose a strategy for choosing something which is out of the order, but people might like it.
Mhm. Yeah.
Good. Okay, so thank you for your comments.
Thank you.